Subject: Design of machine element. Practical number 2. Exercise on material selection for given application. Theory: the selection of proper material for engineering purposes is one of the most difficult problems for the designer. The best material is one which serves the desired objective at the minimum cost. The following factors should be considered while selecting the material: availability of the materials, suitability of the materials for the working condition in service, the cost of the material, physical properties of metal. The physical properties of the metal include luster, color, size and shape, density, electric and thermal conductivity and melting point. The following table shows the important physical properties of some pure metals. Mechanical properties of metals. Strength. It is the ability of material to resist the externally applied force without breaking or yielding. The internal resistance offered by a part to an externally applied force is called stress. Stiffness. It is the ability of material to resist deformation under stress. The modulus of elasticity is the measure of stiffness. Elasticity. It is the property of material to regain its original shape after deformation when the external forces are removed. This property is desirable for materials used in tools and machines. It may be noted that steel is more elastic than rubber. Plasticity. It is property of material which retains the deformation produced under load permanently. This property of material is necessary for forgings, in stamping images on coins, and in ornamental work. Ductility. It is the property of material enabling it to be drawn into wire with the application of a tensile force. Ductile material must be both strong and plastic. The ductility is used measured by the term percentage elongation and percentage reduction in area. 6. Brittleness. It is the property of material opposite to ductility. It is the property of breaking of material with the little permanent distortion. Brittle materials, when subjected to tensile loads, snap off without giving any sensible elongation. Cast iron is a brittle material. 7. Malleability. It is a special case of ductility which permits material to be rolled or hammered into thin sheet. A malleable material should be plastic, but it is not essential to be strong. The malleable material commonly used in engineering practice. 8. Toughness. It is the property of material to resist a fracture due to high impact load like hammer blows. The toughness of the material decreases when it is heated. It is measured by the amount of energy that a unit volume of the material has absorbed after being stressed up to the point of fracture. 9. Machinability. It is the property of material which refers to a relative case with which a material can be cut. 10. Resilience. It is the property of material to absorb energy and to resist shock and impact loads. It is measured by the amount of energy absorbed per unit volume within elastic limit. 11. Creep. When a part is subjected to a constant stress at a high temperature for a long period of time, it will undergo a slow and permanent deformation called creep. Fatigue. When a material is subjected to repeated stress, it fails at stress below the yield point stresses. Such type of failure of material is known as fatigue. Hardness. It is a very important property of the metals and has a wide variety of meaning. It embraces many different properties such as resistance to wear, scratching, deformation, and machinability, etc. The hardness of a metal may be determined by the following tests: Brinell hardness test, Rockwell hardness test, Vickers hardness, also called diamond pyramid test, and Source scleroscope. Thank you.